Greetings, everyone, and welcome to our BGP webinar, Border Gateway Protocol Simplified. It's great to be here for today's webinar as we dive into the basic, fundamental, introductory concepts of BGP. What does that mean? It means that today I'm going to say some things where some of you with a little bit more BGP experience might turn around and say, well, Raymond, you can actually do this as well. You can actually do this as well. Yeah, I know. I do know that. Absolutely. But in order to get to that point where we can get that far, we need to know the basics. We need to know the fundamentals. We have to know how underlying BGP was fundamentally designed, built, and so on and so forth. And then after that, through years and years and years of expansion, we have added. So today's really about the basics. It's about the fundamentals, folks. So it's great to have each and every single one of you here for this introduction to BGP. So we're going to describe important parameters of BGP, because when you don't understand the important parameters of BGP, it's very tough to then get into the advanced nitty-gritty parameters of BGP, because BGP can get really, really crazy, folks. So having a very, very fundamental knowledge of BGP is going to help you do the more advanced things later on. We're also going to build BGP peers today, so we're going to hang out in our lab environment and build BGP peers. We're even going to show you how to advertise networks within BGP. We'll do it two ways. I'll show you the network command today, but I'll also show you redistribution into BGP with connected routes, just keep it simple. And then we'll also take a look at summarization, because one of the most important aspects of BGP and the internet is to not advertise routes that are not necessary. Let's be very clear about that. Do we want to be advertising /25 networks on the internet? No. /26 networks on the internet? No. /27 networks on the internet? No. Right? So if you do own some public networks that are using those particular addressing spaces, right, either you or your ISP, someone needs to do summarization, because we really don't want the internet to be filled with a whole bunch of different prefixes. Even with omitting the /25, 26s, 27s, 28s, 29s, 30s, 31s, 32s from the internet, there's still like 900,000, almost a million prefixes. And I'm going to show you that today with a real BGP router, folks. We're going to log into a real internet-enabled BGP router, and I'm going to show you how crazy it is. And if you've never seen this before, you might be shocked when you see it. So it's great to have each and every single one of you here, folks. Let's dig right in. If you have any questions, comments, or concerns, use the chat area right over here. So if you haven't logged in yet, make sure you log in now, so that way there you can partake in all the exciting discussions we're going to have today. So how many of you, first and foremost, chat in, please, are using BGP in any way, shape, or form? Just yes or no. Are you using BGP at all? Yes. Great. All right. So BGP originally created as the routing protocol for the internet. So for those of you who said yes, if you're using it for the internet, just chat in internet, all right? However, if you're using it for something else as well, or you're not using it for the internet and you're using it for something else, chat in what that is. It might be MPLS, layer 3 VPNs. You might be using it internally in your data center ACI, okay? And the moral of this story, folks, is to realize that there is a high probability you are going to need to work with BGP at some point in time in your career. It's not just the routing protocol of the internet anymore. We use it for a lot of different things. So regardless of what you're using it for, though, the fundamentals are all the same. So you learn the fundamentals once. You can use those fundamentals regardless of which deployment you're trying to do or solution you're trying to accomplish with BGP. One of the things about BGP is it's super scalable. So we can build massive networks like the internet and exchange all those different prefixes because of how BGP operates. So first and foremost, it's important to recognize that with BGP, we are going to be forming what are called static neighbor adjacencies. So in order for you to share information using BGP, the two routers actually have to open a communication channel with each other and form a neighborship. And we do this statically. Now, this is different than your OSPF routing protocol or your eIGRP routing protocol, which you would use primarily inside of your organization for routing purposes. Right? What do we do with those protocols? We enable the routing process on the interface, and then using our hello packets that are now sent out of those interfaces using multicast addresses like 224.0.0.5 for OSPF, and then we got 224.0.0.10 for eIGRP, right? We're using those multicast addresses and those hello packets to form dynamic neighborship. So you're not actually having to define your neighbors. Now, there's some exceptions to the rule, obviously, with all of our protocols, but most of the time, that is how you're forming your neighborships. Well, with the BGP, not the case. You're going to have to go to this router and specify who you're trying to form a neighborship with. So if I'm trying to form a neighborship with this router, I need all the configuration parameters of that other router in order to make sure I do it properly. Likewise, we need a configuration in the other direction. So static neighborships, static addresses, static autonomous systems, as we'll see, those all have to be provided. And on top of that, BGP needs a transport protocol. And what is BGP's transport protocol? It's actually TCP. Right? eIGRP is its own transport protocol. OSPF is its own transport protocol. They don't use TCP. They don't use UDP. So we're dealing with here essentially a service. BGP is a service, an application using TCP essentially when it's all said and done. But it's a routing protocol. And specifically, it's port 179. So with that in mind, you have to make sure that there's no access control lists at all in between wherever you're forming your neighborships that are going to block TCP port 179. So in the end, what do we have? We have a client-server relationship. One of our routers is going to end up using, for example, an ephemeral port number between 49,152 all the way up to 65,535, somewhere in that range. Could be lower than that. I've seen it lower numbers used as well by the client, and then the server is using TCP port 179. So how do they choose who's the server and who's the client? Well, in reality, the way BGP works when you're forming a neighborship is they both try to be the server, they both try to be the client. And then in the end, using things like router IDs, they ultimately figure out, oh, I'll be the server, and the other one's like, I'll be the client, and then they'll tear down one of the TCP sessions. But you have the ability, again, to manually decide, I want you to be the server, I want you to be the client, but it's not something you have to do. It'll figure it out on its own for you. And then once you have those neighborships, you can start advertising NLRI. If you don't know what NLRI is, that stands for Network Layer Reachability Information. So BGP likes to use that term, network layer reachability information. It's just a fancy way to say your prefix with its mask, so like 10.0.0.0/24, prefix and mask, and all the attributes that are associated with that prefix, okay? So what are attributes? Well, let's think about OSPF and eIGRP for a second. We have attributes like what? Bandwidth. We have attributes like delay, potentially, especially with eIGRP. eIGRP, we have reliability. But primarily, something like eIGRP and OSPF, bandwidth is their primary item that they are most concerned about when it comes to making decisions. Well, BGP has tons and tons and tons and tons of attributes that are used. And all of those attributes are either just locally available on a router or shared between routers. And so these are what the attributes are. That's a lot. And most people who are new to BGP look at this list going, what? Excuse me? Are you serious, Raymond? Absolutely, I'm serious. I am telling you right now that BGP does not care about bandwidth. BGP does not care about delays. BGP does not care about reliability. BGP cares about what? Stuff you see here. This is what we call the BGP best path selection process. And so anytime a BGP router needs to make a decision on which path is going to be used to reach a particular destination, this is what it uses. That's right. And it starts at the top, and if these two checks are passed, then we start going down through the various attributes, trying to find one single entry, one single path. As we go down through this, that can ultimately be used. So if there's more than one path, then we have to go down through this. If there's only one path, well, then obviously it's the one that's going to be used. But if there's 2 paths or 3 paths or hundreds of paths, then the router has to go down through this. And so let's right now visit a real life BGP router out on the internet. So this router here is what we call a looking glass router. If you don't know what a looking glass router is, folks, there's many of them available on the internet. You can go to your favorite search engine and just type in BGP looking glass routers, and they'll give you information on how to connect to various BGP routers that are on the internet, so you have the opportunity to connect to them and run various show commands. And the reason why these exist is because when you're trying to manipulate BGP, how do you verify if whatever you did actually took effect out on the internet? There's only one way. You need to access the internet routers and find out. So you could log into these BGP enabled routers and see if what you have done has taken effect on the internet. That's why they exist. That's one of many reasons. But like, for example, if I type in show IP BGP right now on this particular router summary, that is, we're going to see show IP BGP summary shows that this router has all of these possible neighbors. Possible neighbors. And why do I say possible neighbors? Because just because with BGP you configured a neighbor doesn't mean you're actually a neighbor. You really need to look here. Are we up? Are we down? And then have we learned anything from them? So anytime you see a number here in this column, then that means you have a neighborship. And also you'll see a value in the up-down column. But if you see never here, or you see active, you see idle, then you have a configuration for that neighbor, but you haven't formed a neighborship. And it could be one of a multitude of reasons why the neighborship hasn't formed. But you can see this router's configured to possibly be neighbors with a lot of different devices. So what I'm going to do here is I'm going to clean this up a bit. I'm going to say pipe to exclude active and idle. So that way there we can just see the neighbors that it actually has, that it really formed neighbor adjacencies with. All right, so this is our list of neighbors that we have on this device now. And what you'll see here on the right-hand side is that we have learned 913,902 networks, prefixes, and their attributes from that router alone. 914,000 from that router alone, and so on and so forth. That's a lot. That's a lot. So if you are connecting a router to the internet, a BGP router to the internet, it has to be one that has the ability to learn all of that information and store all of that information in its memory. So if we go to the top here, it'll even tell us that there are 969,290 unique network entries that this router has learned about on the internet. Wow. Okay, but this is what blows my mind. It has learned 18,729,582 networks. Okay, now out of this number here, there's a lot of duplicates, a lot of repeats. So if you add up all these numbers here, that's what this number is. But then it goes through it and says, okay, how many of them are actually unique? Well, there's 969 unique ones on the internet. Right, so if we look at them, we can see that by typing in show IPBGP, and there is the network. So you'll see here that we learned about 1.0.0.0/24 from all of these possible neighbors. If we look at these numbers here, these are the same numbers we see here. Same numbers we see here for the addresses. So we've learned about this one from all of them. And these are the attributes, folks, right here. But there's more attributes than just that, because I'll type in show IPBGP 1.0.0.0/24, and there's your attributes of BGP for each and every single entry that we've learned from the neighbor. So this one here is for 1.0.0.0, and then as we from one neighbor, so it's from, all right, so there's one there, okay, one there, one there. Keep going down. There's another neighbor there. There's another neighbor there. So each one of these is advertising 1.0.0/24 with what? With the attributes And then I, as the router, has to go through there and pick just one, the best one. And if we go back to the BGP table, it tells us that this is the best one. That's what the greater than sign means, if you didn't know that. All right. So the greater than sign means that we chose that as the best one. And it's the best one that goes in our routing table. So we're going to type in show IP route now. And you'll see, remember 4.68. You'll see in the routing table 4.68 for 1.0.0.0/24. Right. So that's what those attributes are used for. We're not going to dig into all of these attributes. We're not going to dig into the process of these attributes. I'm not going to demonstrate these attributes to you and how we can manipulate them or anything like that. We'll save that, folks, for another webinar, another day, if everybody really wants to have a webinar about that. But if you're itching to learn more about these attributes, check out the Encore, the Cisco Encore course that we offer. I teach all of this in that course. And then also the other one that does it as well is an RC, ENARSI. So Encore, Enterprise Core Technologies, CCNP, and an RC is all about advanced routing. That's what it is. So that is also a CCNP course. So you can check those out if you want to. So Vincent's asking, those 900,000 routes, is that something that could have broken the internet back in the day with the 512K issues and stuff? I'm trying to remember about that in 2014. But yeah, one of the challenges we face is as the internet grew bigger and bigger and bigger and bigger, a lot of routers didn't have the memory that was required to store all of those various possible routes that they were learning out on the internet. So yeah, you definitely need a router that has the space, the memory space that is capable of storing all this information, but also the processing capabilities to go through all those attributes for each and every single one. Now, most of us as enterprise admins, network admins, we're not typically going to be dealing with the entire internet routing table because we don't necessarily need it in the grand scheme of things, because if we're going out this way or we're going out that way, we could definitely have a much smaller internet routing table. And that's where more advanced things like route filtering comes into play, and telling your router, we don't want this, we don't want that, we don't need this, we don't need that. And that way there, it's not having to deal with all of that stuff anyways. Yeah. So this is all full routes, right? Full routes. Most of us are not going to need the full routes on our own routers in our enterprise environment. Right. Right. So another key concept in regards to BGP is autonomous system numbers. So what is autonomous system? Now, first of all, many of you who are using eIGRP are familiar with the term autonomous system. But the thing is eIGRP uses the term autonomous system slightly differently, because with eIGRP, your autonomous system is your collection of eIGRP routers that are allowed to form neighborships with each other and share routes with each other, all right? So with eIGRP, an autonomous system is your collection of routers that are allowed to form neighborships with each other and share routes with each other. Whereas with BGP, an autonomous system is a collection of networks overseen by one organization, meaning that my company is an autonomous system. Your company is an autonomous system. Cisco's an autonomous system. Facebook's an autonomous system. ISPs are autonomous systems. So let's think about it this way. Let's pretend this is you, all of you, okay? Each and every single one of you, position yourself here. Right? That's like your ISP as an example. Let's say that's us. So there's us. We are our autonomous system. There's the ISP. And so all of the routers in here are being what? Being overseen by a single organization, overseen by a single organization, overseen by a single organization. However, they are doing it. Inside of the autonomous systems, typically you're running protocols like eIGRP or OSPF as enterprise networks. Some of you might be using ISIS now, especially if you're doing SD access stuff. But between autonomous systems, folks, this is where BGP comes into play. Or for many of you, MPLS environments, right? You're using BGP as well for that in the MPLS environment. But for the sake of our discussion here, we're going to go with the internet examples to learn the basics of BGP. So we have EGP, an exterior gateway protocol between different autonomous systems, multi-protocol BGP. And why is it called multi-protocol BGP nowadays? It's called multi-protocol BGP nowadays because it has the ability to support many different things. For example, IPv4 prefixes. That would be one address family for BGP. One protocol, IPv4. But you got IPv6, that would be a different address family, a different protocol. So you configure in the IPv4 address family, your IPv4 stuff. You configure an IPv6 address family, your IPv6 stuff. But then you also have things related to your MPLS. So your layer 3 VPNs, you'd configure that under that address family. For IPv4, you got your IPv6 VPNs that would be configured under that address family, and a whole lot more. So BGP can do so much. It's not just about IPv4 internet anymore. So we call it multi-protocol BGP. And if you really want to get specific, it's version 4. All right. So each and every single autonomous system needs a number. So you got to get your numbers from your ISP or a regional registry, just like your IP addresses. So IANA is also responsible for handing out our autonomous system numbers to the regional registries or ISPs, just like our IPv4 and IPv6 addresses. And so when it comes to autonomous system numbers, originally we had this range. Publicly, these numbers were available. And then privately, you could use these just for goofing around with BGP for documentation purposes inside your own environment if you weren't connecting to the internet. But if you're on the internet, you typically have a number in that range. But then we ran out, just like we ran out of IPv4 addresses, because everybody got out of the internet. And so now you might have autonomous system numbers that are a lot higher than 65,535. Well, it's not might, you will, right? You will. All the way up to publicly, that number there, I won't read it out for you. You can figure it out yourself. And then there's a private range up above that as well. So you have the ability to do that. Now, when it comes to the public addresses, if you get one from your ISP, always remember this, that typically that is bound to the ISP because they would have gotten it from a regional registry themselves, and now they're giving it to you. So typically it's bound to them. So one of the things to always think about if you're getting an autonomous system number is, do I ever plan on leaving this ISP? And I want to take the autonomous system number with me. If you do, it is always recommended you get your autonomous system number from a regional registry instead of your ISP if you can. That way there it's portable, it's movable, it's easier for dual homing scenarios and a bunch of different things like that. But hey, if you know you're going to hook up with this ISP, you're just going to connect to this ISP, you're not doing anything too crazy, then typically that autonomous system number from the ISP is going to give you what you want. Just do your homework when it comes to autonomous systems and the benefit of getting it from the ISP versus the regional registry before you make a decision. So that way there you don't have to go back and change things after the fact. Right? Another thing to keep in mind about these autonomous system numbers is that it actually is also going to define who owns the IPv4 networks or IPv6 networks associated with it. So when you look at this autonomous system here, I am pretending that this autonomous system owns that particular IP addressing space. So if we go out on the internet right now, the good old internet, what might we want to look up? Well, let's look up who owns autonomous system number 109, meaning who has been given autonomous system 109. The answer is Cisco. So anything related to autonomous system 109 is Cisco. Harvard has autonomous system number 11. The UK Defense Research Agency has autonomous system number 7. MIT uses autonomous system number 3. Intel has 99. Right? This is all publicly available information that you can find with simple lookups. Right? But then the question is right, who owns a particular IP address or network and what AS is that associated with? So here you can see that I looked up who owns this network right here. Well, that happens to be Cisco and AS109. So I actually know that particular public IP addressing space is tied to autonomous system 109, and autonomous system 109 belongs to Cisco. So here is Cisco right here. And there's their autonomous system. So in that data center associated with autonomous system 109, I can reach the different networks that are associated with autonomous system 109. Right? And what happens here with BGP is that when you advertise from your autonomous system to other autonomous systems, your networks, well, then everybody gets to start learning out on the internet. So for example, if we go over here, this autonomous system advertises that out. Eventually, that information is going to make its way over to me. And it's up to my routers that are running BGP to ultimately figure out, using the BGP best path selection process and all those attributes, which way are we going to go. So really, it's about, the internet is really about all these different autonomous systems all connected together, all running BGP and sharing all of that information, and everybody playing nice. And if anybody doesn't play nice, that's when the internet has problems. Right? And can one autonomous system have multiple public IP addresses? Absolutely. Absolutely, yes. I believe Autonomous System 109 has more than just 12.5.186.0. I just don't know what they all are off the top of my head. All right, so let's talk about forming our neighborships now. Let's get into some config. So we've got eBGP and iBGP. What's the difference between the two? Well, eBGP is about forming external border gateway protocol neighborship. So appearing between directly connected routers in different autonomous systems. So for example, connecting from here up to here, different autonomous systems. Whereas iBGP is about peering between any routers within the same autonomous system. So for example, an iBGP peering would be here, where an eBGP peering here. And based on how you define your static values when you're doing your configuration, ultimately determines in the end whether it's iBGP or eBGP, as you'll see. You will not have to specifically say, oh, I want this to be iBGP, or I want this to be eBGP, as you'll see here momentarily. All right, so from a configuration standpoint now, folks, let's go ahead and do an eBGP peering between R2 and ISPA right now. And we are going to do it from here right up to here. So the pieces of information we're going to need to be successful here is, what is the IP address here? What is the IP address here? What is the autonomous system number here? What is it here? And yes, we're going to configure the ISP side as well, so you can see what's happening on both sides. Now, in reality, the ISP would do their side, you would do your side, everything magically works, hopefully, and there's no problems. But here's what's happening on both sides. So on router number 2, we are going to type in the command configure terminal and then router BGP, and we'll specify our autonomous system number, so 65,012. Now, one thing to point out is that your router can only belong to one autonomous system. So even if I now accidentally mistype it, it yells at me and says, no, one autonomous system are Cisco iOS routers. All right, perfect. So, for those of you who know about some more advanced scenarios like VRFs and other things like that, well, you'd still have your one autonomous system, but then you could break out the different address families, as I was referring to a while ago. So just one autonomous system. All right, so there it is. Now what do we need to do? I need to define the neighbor. That's what I need to do. So I need the IP address of that device. So I know it because it's my equipment, but if I didn't know it, I'd have to contact my ISP as an example. What is the IP address I need to use to form the BGP neighborship? And they're going to have to tell me, because if they don't tell me, I'm going to have to figure it out some way, or else I can't do the BGP neighborship. It's easier for them to tell me. But wait a second. We cannot form a neighborship unless what? We can establish a TCP session. So first thing we want to do is make sure that you can actually ping that address that you want to form the neighborship with. Because if you can't ping it, then there is no way you're going to be able to form a neighborship with it. So number one, check to make sure you can actually reach that IP address. If you can't, then you got to solve the underlying routing issue to reach that address before you can even configure BGP. Because BGP relies on a TCP session in order to work. So you got to be able to reach that address. All right. So now we'll type in the neighbor command, and it's going to be 209.0.113.89. So I opened up my email from my ISP, and they told me that that's the IP address. And then I have to specify their autonomous system number, theirs. Okay, so I'm on R2 right now. So I put in their IP address and their autonomous system number. Now, because I put in this number here and my local number is this, that right there means eBGP. That's what it means. So I don't have to say this is eBGP. Just by having those numbers different means eBGP. So we're all good there. All right. Now, there's another thing that you don't technically have to do, folks, for IPv4 neighborships, but I encourage people to get in the habit of doing this nowadays, and that is actually go to IP address family, IPv4 unicast configuration mode. And what you do is you type in this command here. Now, this happens automatically for you with IPv4, but with BGP, any other address family you work with, the neighbors don't automatically get activated at all. So it does for IPv4, but it doesn't for anything else. So I tell people, just get in the habit of doing this command, because down the road, when you're going to have to do your VPNs, you're going to have to do IPv6, you're going to have to do other things, you're going to have to know this command. So just get used to typing it in. Not only that, now if we go to our configuration, you're going to see here that it actually shows I have an address family IPv4 configuration. So if I had IPv6, I'd have a different address family for that. For VPNs, for MPLS, you'd have a different one, and so on and so forth. So just get used to doing that. And what this allows you to do is, if now I wanted to have a neighborship for VPNs, or I wanted to have a neighborship for IPv6 or anything like that, I can just activate that neighbor in the address family, and I don't have to go back and create another neighborship. Right? So Vincent, I'm going to get to that very shortly. All right. So just get in the habit of doing that, even though it happens magically for you with IPv4. When you manually typing in, it's going to actually create the address family for you instead, which is what you want. You want your config to look like this going forward. It simplifies everything. All right, so now that we're done this side, what has to be done? We have to go to the other side. But before I do that, let's type in do show IP BGP summary and check the neighborship. So you'll see here that it actually says I have a neighbor, 203.0.113.89, but it's not true. I have a configuration for a neighbor in Autonomous System 65,000 using BGP version 4. Notice here it says never and it says idle. So what does idle actually mean? Well, when you learn more about BGP, what you'll learn about is that we have our different phases that we have to go through until we fully establish our neighborship. These values here, if you ever see them, this means you have a TCP problem, meaning your TCP session is not being established. Why? Maybe you don't have a route to that IP address. Maybe the router has not been configured to talk back to you, so it's not even talking back to you at this particular point in time. But idle means we're waiting to try again. Whereas active means we've tried, we're trying again, and if it doesn't work, we just keep looping and looping and looping and looping and looping and looping and looping until the problem is actually solved. Once the problem is solved, then we can go down and finish up, and these are our BGP messages now that are being exchanged. So this is really all about a TCP related problem, whereas this would be more of a BGP related problem. And your goal is to ultimately get to established. That's what your goal is in regards to that config. So that's why it says idle there right now. It's simply because we don't have the configuration done on the other side. So there's no TCP response coming back for us. So what we're going to do is we're going to go over to the ISP router and we'll log in. We'll type in, again, I would not in the real world have access to this router, but because this is a demonstration, I have to show you what the ISP would be doing on their side. So they would type in their autonomous system number. They would then have a neighbor command that points back to me at 203.0.113. My IP address is 91 in this case. Yes, it's 91. And we're going to put in remote autonomous system. and it's going to be 65,012. Again, that means to the ISP, it's an eBGP neighbor adjacency. And then we should see here momentarily that, and notice I didn't use the activate command. I encourage people to activate, but even though I didn't activate, you see it happened automatically for me. So we are up. So I do have a BGP neighborship now. If we look at the output of do show BGP summary, we're going to see here that we have our neighborship with 91. Now, how do I know that? I know that because you can see the timer shows me that we actually are up, and because it's counting up, and there's a value here. It no longer says idle. It doesn't say active or anything like that. We can see here that it is a value of 0. Now, something to note here also is that if I take a peek at do show IP BGP, and let's go to our neighbor, and specifically this address here, we can get more details about the neighbor. And so you can see the state here actually says established. So we've successfully established our neighborships. But let's go back to what Vincent asked. Vincent said, can BGP sessions be established between non-local routers? So routers that are not directly connected together? Absolutely. And you'll notice down here that it says here that we have a time to live. This time to live is about how close you essentially have to be to form your neighborship. So for example, it says a minimum incoming time to live of 0. So as long as the packet has a time to live in the packet header of 0 or greater, then I can go ahead and use it as a BGP router. However, right now, I'm only sending values of a time to live of 1. You see that? 1. That is because eBGP equals a time to live of 1. Because it's an eBGP neighbor, by default, we must be directly connected. Okay, we must be directly connected. Right? However, can we change that? Absolutely. You can change it. There's a command for BGP that allows you to change the actual time to live. So the max you could go up to is 255 for that. And then based on that, you could be further hops away. And so iBGP actually defaults to a time to live of 255. So if you form an iBGP neighborship, you can be up to 255 routers away and still form a neighborship. You don't have to be directly connected. But eBGP expects it to be directly connected, but it doesn't have to be. You can change that if you want to. All right. One other thing. Oh, somebody wants to see the activate command. It would just be a matter of me going to address family, IPv4, unicast configuration mode, and then typing in neighbor, putting in this, and then typing in activate. That would be it. All right. All right, so that's the one we just did on the ISP. That one there, and that one right there. Right? Yeah, that would be the eBGP multi-hop command. That's exactly what that'd be. So you change the hop count with the multi-hop command. Yep. To change the time to live. All right. One final thing is authentication. It's really important that we protect our BGP neighbors. So we want to do authentication. So that's a critical thing at a basic level to do. So what you have the ability to do when you're forming your neighborships is type in the neighbor command again, and then type in the IP address of the neighbor that you want to have your authentication with. And then you type in the password command, which uses MD5 automatically. So you don't have to worry about service password encryption. You don't have to worry about setting any secrets or anything like that. You just type in password and it uses MD5. And let's use the password, let me in. There we go. Now I'm going to force a BGP TCP reset on this router right now. This is never recommended on the internet unless you have no choice. Because what it does is it causes ripple effects through the internet. Anytime a neighborship goes up, down, up, down, up, down, it causes a ripple effect through the internet. So it's not a best practice to do hard TCP resets for BGP. Okay, the recommendation is more to just tickle the other router with the command clear IP BGP star in. If you add the in keyword, it's called a soft reset. If you do the out keyword, it is another type of soft reset. So, update stuff coming in, update stuff going out, but don't actually reset the TCP session if you add the in or out keyword. If you forget the in or out keyword, it's a hard TCP reset, it's known as. All right, so you can see now, as we try to reform the neighborship, the other device does not have the right password, and it's telling me it doesn't have the right password. All right, so let's go over to ISP-A and show you how to set that up. You just go over and you type in neighbor, the IP address of the device you want to do the password with, or the authentication with, and let me in, make sure it's the exact same. And again, it's going to use an MD5 hash automatically. So we should see now our neighborship should form pretty quick here. Does BGP just rely on a trust system for inputting the correct autonomous system number for yourself and neighbors? Well, here's the thing. You have to put in the correct autonomous system or the correct IP address in order to form that neighborship. Because if you don't, you're not going to form a neighborship. If you put in the wrong numbers, nothing happens. And depending on syslog message, it might tell you the wrong IP address has been inputted or nothing. Typically, it's nothing for the IP address. It won't tell you anything. It'll just stay in the active and idle state. But if you put in the wrong autonomous system number, typically it'll tell you it's the wrong autonomous system number. Because what happens with BGP is it looks at the IP address, it looks at the autonomous system number, and it compares it to what's arriving. And it says, is that the same information that's arriving? So if I put in the wrong information on my end, the ISP, when they receive that, they look at that and they're like, well, that's not the right information that we're expecting based on our config. So, because it compares that as the incoming packets, outgoing packets, and different things like that. Yeah. All right, so that is our password config. So we are good now. Do show IP BGP summary. And there's a simple BGP config right now. Run pipe to section BGP that we have. And there we go. Pretty straightforward. It's the neighbor command that we've used 3 times so far. And folks, there are some configs where you'll use the neighbor command 5, 6, 7, 8, 9, 10, 11, 12 times, and so on and so forth. So yes, BGP configs can get very, very, very lengthy on you. All right, now let's talk about our iBGP configuration now, because I already pre-configured this eBGP neighborship for ourselves, so that one's already done. I've already done this one as well for the sake of time. So let's do an iBGP neighborship right here. So the first thing for us to recognize is that with iBGP neighborships, you're probably going to have multiple paths to reach the neighbors through your environment. So we have this path, we have this path, right? There's 2 different ways. We have this way, we have this way. So there's 2 different ways to reach that neighbor. So what we need to realize is anytime a BGP message is sent, the source IP address of the BGP message is going to be the outgoing interface, And so because there's multiple paths, the outgoing interface is chosen based on the underlying routing table, which means the source IP of the BGP packet can change every time. And so if this neighbor is expecting a certain IP as the source and it gets a different IP in that source packet, then the neighborship's not going to form. Right? That's an example of just having the wrong IP address to form a BGP neighborships. So in the end, right, the goal or the recommendation is to use, for example, a loopback interface. So we've got a loopback interface here that I've created. That I've advertised into my interior gateway protocol. So if I type in do show IP route, we're going to see here that I can reach 192.168.255.1. And if I go over to R1, we'll see that I can reach 192.168.255.2, which is R2. So now what we're going to do is we're going to form our neighborships using those addresses instead. So that way there, no matter what interface is used to send the BGP message, we're always going to be sending from 192.168.255.1 and receiving at 192.168.255.2 regardless of the physical interfaces. And we're going to do the same thing in reverse. So that actually requires 2 commands for us to be successful now. So what we're going to do is we're going to get into our configuration mode here. type in router BGP 65012. All right, and now we're going to type in neighbor 192.168.255.2 remote autonomous system, and it's going to be 65012. That right there tells the router iBGP. That's what that does. So now it automatically knows the time to live is 255. So I can be up to 255 routers away, and I can still form a neighbor adjacency. Right? However, what is the source address going to be? I need this command or this is not going to work for me. Because I'm using the loopback interfaces, I have to tell the router anytime you talk to this neighbor, I want you to use the IP address associated with that interface, loopback 192, meaning use 192.168.255.2 because that's the IP address of that interface. So now I'm sourcing all the messages from 192.168.255.1, and they're destined to 192.168.255.2 for my iBGP neighbor adjacency. So we got to do the same thing on R2 now. All right, so now we're going to type in on router number 2, neighbor 65012. Oops, no, neighbor. The IP address 192.168.255.1. Remote AS, and then neighbor update source. In this case, it's also my loopback 192 interface. All right, so there we go. Our neighborship is up, and so we're sourcing from our loopbacks, sending to the loopbacks, and vice versa. Do show iBGP summary, and now we've got our iBGP neighborship as well. So R2 has its iBGP neighborship with R1, and it has its eBGP neighborship with ISPA. All right, so if I type in do show IP BGP neighbor and we look at this address here, folks, just to show you, look at the time to live right now. Down here, you'll see the time to live is set to 255. So iBGP defaults to 255 hops for neighborships. Anything less than that forms a neighborship, whereas eBGP is 1 by default, but it can be modified if you want to modify. All right, so we have all of our neighborships. I know I didn't show you how to configure these two or these two, but it's the same thing. So if you go over to your ISP right now and you take a look at do show run pipe to section BGP, what do we end up with? Woo! Look, the config, right? All those neighbor commands forming all our neighborships and so on and so forth have been done in that particular case. So you're just adding neighbor commands for every neighbor you need. So you remember that internet-enabled router I showed you a while ago? Man, right? Like think about the number of neighbor commands on that router. It's incredible. Absolutely incredible. All right, so with that said, we want to now move on to advertising networks. It's not that hard to advertise networks with BGP, but you have to understand the rules associated with advertising. So let's talk about network command and redistribution command. So first of all, the network command for BGP is purely about taking a network ID that you have in your routing table and importing it into the BGP table. That's right. So if it's not in the routing table, the network command does nothing. It has to be in the routing table. So the BGP, you're importing routes from the routing table into BGP that you can then share with other BGP routers. And it has to be an exact match to the network command. So if you mess up on your network command and it's not specifically pointing out an exact address that's in the table, it's not going to work. It's going to ignore your command. It'll keep it and ignore it. Won't throw any errors because it doesn't know any better. Right? So in this case, we have right now these public networks over in my environment. So what I want to do is I want to show you how to take these, inject them from the routing table into BGP, and then once that's done, it's going to get shared to everybody. So once something's in your BGP table, you can share it. So let's take that and dump it in right now. So we'll go over to R2. Let's type in do show IP routes so we can see those routes that they are actually in our routing table. Right there they are right there. So now we're going to go to our router, BGP configuration mode for 65012. Let's type in do show IP BGP to take a look at our BGP table. Right now it's empty. There's no BGP learned routes whatsoever. So let's train this router by importing stuff from the routing table, like these OSPF routes, and bring them in with the network command. So we're going to go under our address family configuration mode for IPv4 unicast, because it's IPv4 addressing, and we're going to type in network, and it's got to be an exact match. So it's exactly this address with this very specific mask. If I type in the wrong mask, let's say I type in 252, do show IP BGP, nothing. Look, there's nothing. Nothing. Why? Wrong mask. Let me go ahead and remove that. And let's put in the right mask. All right, we put in the right mask now, and what do we get? Let's look at the BGP table. Now it's in. So we've injected it into our table. All right, so now let's go ahead and add the other 3 with the network command. So we had 8, we had 16, we had 24 based on our topology. Do show IP BGP. So now I have all of those injected into my BGP table locally on my device. And how do I know? Well, I know I own them because there's nothing here. There's no autonomous system number listed here. That's me. That's mine. These are mine. These are mine. Right? But now let's go over to the ISP router. Because I brought them in, I can share them with the other BGP routers. Look at this. And you'll see it says they are owned by this autonomous system number. So whatever autonomous system number is at the very, very end, folks, at the very, very end, that's who owns it. So if we look at show IP BGP, 13,335. Look, it's the same number in the very end of the path. That's who owns 1.0.0.0. So if you looked up right now, who owns autonomous system number 13,335, or who owns 1.0.0.0/24, you're going to get the answer for that. And then this one here is 38,803 owns that prefix. 38,803 also owns that prefix. So that's what that is telling me when it's all said and done, my AS path. So let's go over to your router here, who has a neighborship with the ISP. If we go over to that router and type in show IP BGP, what are we going to see? We're going to see that you've learned about them as well. But look at the AS path. You see how it's growing now? Because I own it, 65,012, and the ISP has shared it to you, 65,000. So you know to get to those networks, you have to go to here, you have to go to here. Just like that. That's what BGP is doing for us. Okay. Let's say we wanted to advertise a default route. We could do that with the network command as well. For example, you'll see here that the ISP has a default route configured. What we're going to do is we're going to use our address family IPv4 unicast. And let's just type in the network command 0.0.0.0, 0.0.0.0. Forgot the mask keyword, but that's what it would be. And now you see do show IP BGP. There is the default route now injected in the BGP. And if we go over to R2, R2 has learned about from the ISP a default route. Also, take a peek that it's also been learned from who? It's been learned from router 1. You see that? Right? This is interior border gateway protocol. So I've learned it from R1 as well. And I've learned it from someone external to me. And how do I know? Because if you look right there under the I means iBGP. And under the I, you see how there's nothing on this line or nothing on this line? That means eBGP. So if it's blank after the greater than sign or blank, and then that means eBGP. But if you see an I right there, that means iBGP. So that's for my iBGP neighbor. That's where that one came from. So that is the network command. As you can see, you've got to be perfect with it. You got to get the actual network ID, the right subnet mask, and then it's going to be imported into your table, and then it's going to be shared. Let's talk quickly about redistribution now. Over here on ISP, look at these two networks right here. Well, if I go to my address family configuration mode on the ISP and I type in redistribution, which is about importing existing routes from the routing table into the BGP table and advertising to the neighbors without using the network command, right? So in this case here now, we could redistribute from connected routes, static routes, OSPF, eIGRP, different things like that if we wanted to. So in this case, I'm going to type in connected. The thing is that we have to specify a route map in this case if we want to get specific. So I only want those two. So this is a little bit more stuff than basic beginner stuff. But let's type in do show IP prefix list. And what we're going to see is that I have a prefix list that calls out, that singles out those two networks. It says 8888/32 and 112.112.112.112, okay? Then you take this prefix list and you have to put it in a route map. Right? This is where things can get a little bit tricky with BGP. So you take your prefix list, you put it in a route map, and I'll learn all about prefix lists and route maps and things like the NRC course, the advanced routing course. But you'll see here that my route map says, hey, let's take this prefix list and dump it into here. And what this is basically saying is we are focused on those two addresses. So now I can call the route map in BGP, all right? So BGP uses route maps for a lot of the things you want to do. That's why I have to do this, okay? So I have my prefix list, which calls out the two networks. I then have a route map, which brings those two networks into this route map construct. And then when I type in redistribute, and these are connected routes in my case, and then I say use the route map, this one here, it says I only want to now redistribute. I only want to redistribute the connected routes of this and this. I had to do all of that just to accomplish that. All right, so let me do that. So redistribution. Now look at do show IP BGP. There you go. Now they're in the table. And since they're in the table, what can we do with them? We can go ahead and we can advertise them. So over here, for example, on R2, if we type in show IP BGP again, what do we see? We see that. So the route map gives me the opportunity to manipulate attributes with BGP, manipulate routes with BGP. Route maps give me flexibility in order to do so many different things with BGP. It's mind-boggling, folks, when it all comes down to it in the end. So you'll learn more about route maps down the road, but it's a way for you to call out different things, specific things, match things, set things, change this, change that. That's what route maps do for us. Okay. But the idea here is to realize redistribution can be done to do what? To take those routes from the routing table, import them in, and share them. Now, one last thing here to think about with BGP is the fact that we do not want to overwhelm the internet ever, 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 ever. So what we want to make sure is we're doing summarization. Most ISPs will be very upset if you send /25s, 26s, 27s, 28s, 29s, 30s, whatever, into the internet. So we really have to take care of advertising. Now, summarization with our advertising. If for some reason you don't have the opportunity to do summarization, then your ISP is going to have to do it. So that's what we're going to do today. We are going to have some fun here. We are going to take whatever we had here, which are not showing up on the screen right now. They'll show up on the next screen. That came here, all those different /29 networks. We're going to summarize them down to here. So that way there you don't receive all the /29s. You're going to receive something that is much, much more compact instead of all these individual /29s. That's going to be our goal. But for example, let's say you didn't want to advertise all of these this way. Well, then you could summarize them yourself as well. So instead of advertising all of this, you could advertise this instead, because this includes all of that. And that's highly recommended. If you can do summarization, do it. And so for us here, because they're contiguous networks, we're just trying to find here in a binary standpoint, I've got 8 binary bits that are the exact same, 8 binary bits that are the exact same. And if we keep going through this, we'll see that all of these are the exact same as well. So that's another 6. That's another 6. So 8 plus 8 plus 6 equals 22. So there is my new subnet mask. And then if I take this, that's the first one there, combine all that together, this would actually be my summary now. And if you need help with learning summarization, we teach that in Encore, we teach that in an RC. So great places to learn a lot of these different things that we're going over that you need to know for BGP as well. So, you know, the fundamentals say we have to summarize. We should be doing this. We should be doing that. But it requires us to get deeper into the knowledge of how you do all those things as well down the road. So BGP is a beast when it's all said and done. All right, so in our particular case, let's have some fun with these ones here. And so in my scenario here, I have determined that my summary is actually 203.0.113.0/ and we can go ahead and we can do a, what's it going to be? What's it going to be? 24, 25, 26. So 26, which ultimately equals 255, 255, anybody correct me if I'm wrong in regards to that summary. 192. All right. So that's what we have when it's all said and done. So here's the thing. You can do summarization anywhere on the internet. I'm serious. Okay? You can summarize what you know. I can't summarize on another router, obviously, but if I have a bunch of routes that I have learned and I'm like, hey, I want to summarize that, you can summarize them. So right now, this is what R2 has advertised out. The ISP is like, no, we got to summarize that before we ship it off, to the rest of the internet. So let's do that on the ISP right now. So let's go to branch first. Those are the networks showing up on branch. So in the end, the goal here is for us to see that branch now has a summary instead of all of these. So ISPA, what we're going to do is we're going to type in summary. No, it's aggregate address is the command, not summary. Aggregate address. And then we just put in that address that we came up with. So 203.0.113.0. And /29 becomes 26, 192, 192, 26. Okay, so we're going to put in now 255, 255, 255, 192. Could be a 27, can it? Can it be a 27? Trying to do it in my head right now. I think we can get away with a 27, can't we? Yeah, we can get away with a 27. But here's what I want to show you. If I type in do show iBGP, take a peek at this. You see, it worked. It worked. Why? Because I have at least one route that matches or falls within this. So what does that mean? It means that if you make a mistake, could you ultimately cause problems for other people? Potential, right? Potentially cause problems. BGP is a big, giant sandbox that everybody's playing in, folks. Think about when you were younger, if you can remember that back that far. Did you accidentally ever kick sand on somebody or kick sand in somebody's face and then your little sandbox fight broke out and you threw sand at each other, right? Yeah, it can happen on the internet. So the key here is to always be extra careful when you are dealing with BGP and you are working with it, because you have an effect on many other groups, routers, networks, information that is out there, right? So always keep that in mind. So do show IP route or do show IP BGP. And you'll see here that the 27's in there right now. I believe I removed the other one. No aggregate address. There we go. Okay, so let's go to branch, and we're going to see that we have a problem still. That's right. And what is that problem, right? So we're not going to worry about 27 anymore because I removed it, so it's going to take a little bit of time. The problem we have, oh no, 27 is the one we want to do. So 27 is that the other ones are still there. And you might be saying, oh, we just have to wait longer. We just have to wait longer. No, 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 no. Why is that? The reason why is because when you use this command, aggregate address, It means create an aggregate address and advertise the aggregate, the summary, and all the original routes. Okay, that's not what we want. You have to add this keyword. And many people forget that keyword when they're doing it. And that's what I mean. BGP can be so difficult at times because it's like, well, all I wanted was the summary. Why is that not the default? Well, it's not. It's advertise the summary and everything else. If you want just the summary, you need the summary only keyword. All right. BGP. All right. It's one of those love-hate relationships you're going to have with BGP. But now look at what we have. Accomplished our objective, correct? 203.01.13.027. So that's how we can go ahead and summarize when we are dealing with BGP, folks. All right, so let's just take a quick peek here just to show you. So if we look at this router, show run, pipe to section BGP, what are we going to see here? You're going to see that, our config is going to be based on basic neighbor commands. But if we go to ISPA, do show run, pipe to section BGP, right? You build and you build and you build and you build on top of your config. So yes, BGP configs can get really lengthy in larger networks. And so there's a challenge of managing that as well. And there are other tools and features you'll learn about down the road that help you manage your config better. There is, right into the iOS, but that's beyond basics. That is totally beyond basics, right? But yes, it can get crazy. So learning those other skills as well on how to keep things cleaner in your config is going to be important down the road. All right, folks. So we have been able to successfully cover our basics of BGP in regards to what is it all about. We have been able to successfully cover our configuration of the eBGP and iBGP, and we have done our network command, our redistribute command, as well as our summary address command. And I want to thank each and every single one of you for taking time out of your busy schedule, being here today with us in this webinar as we've introduced you and gone through the fundamentals of BGP. If you are already a member of the Stormwind family, I want to thank you for being here. I want to thank you for taking the time to hang out in our classes and to learn and trust us with everything that you are trying to accomplish in your careers. But, if you're new, you've never been with us before, you're not part of the Stormwind family, folks, we want to encourage you to become part of this family. We have over 260 engaging virtual instructor-led videos and courses and that you can take advantage of. IT courses, cybersecurity, AI courses, project management, ITIL courses, right? Whatever interests you, folks, come check us out. Let us be part of your journey, your knowledge improvement journey. Many of our classes come with labs, practice exams, multitude of study resources. So that you have the opportunity to, one, prepare for and pass exams. But if that's not what you plan on doing, you're still going to get a wealth of information that is going to help you achieve what you need to achieve day to day in your environment. So take advantage of everything we have to offer. We really encourage you to continue your learning journey, your learning process to make yourself a more valuable individual. So if you look in the chat area right now, Colin has put in this link. So if you're trying to click the screen, try to click the screen, and you're drawing images on my face and stuff like that and giving me a mustache and everything else, that's fine. But if you can't click that link, you're going to have to go over to the chat area, right? So go to the chat area, click that link, check it out, folks. We are offering you a discount if you sign up within the next few weeks. So read through that, and at any point in time, ask questions. Reach out to us, ask questions, contact Mike Fajan. We'll be more than happy to provide you with any additional information you need or hooking you up the multitude of courses so that way there you can continue to learn. All right, so folks, if you have any questions, comments, or concerns, chat them in. We're here. We'll stick around for a few moments so that way there you have the opportunity to ask some questions. But for those of you who need to leave, bolt for the door, thanks again for hanging out with us for another webinar, and we'll see you in a future session with us here at Stormwind Studios. Take care, everyone, and bye for now.